Hello, I'm Rashid. I would like to thank everybody that organized the ICTCM 2020 virtual conference. Thank you very much. Uh, our topic today is integrative learning in college algebra. This presentation is made by Dr. Ram Mohapatra, mathematics professor at UCF, and Rashid Eid Malam Lahsan. I'm math instructor at UCF. We would like to thank you as well for watching the video, and if you have questions, please email us and we will be happy to connect with you, and hopefully we'll see everybody safe and well in ICTCM 2021. When it comes to college algebra and other courses, we may ask why do we need to do, for example, integrative learning, why we need to do some connections. Because college algebra has many issues that we know. Students can come with a wide variety of skills. They also bring different interests and measures. So there is multiple things happening. And one thing we need to address is connect the student with the course. Now this is becoming very essential because the student may not see the need for the course or may not have interest in the course. So we know that. We need to connect the course with the general education program itself. Just because the course is part of this program doesn't mean it's going to express it. So it's more of kind of loose connection there. So the purpose is something like this. We have a student, we have the course, we have the program, and make these connections. Because if we make this connection and we're able to connect the student to the program itself, then the students will not, resist taking a course in a general education program. And hopefully we can do these connections and will improve the motivation and relevance. So what is the current status of general education program? We know they have been changed, right? They used to be cohesive programs and now they're flexible and students have a choice of lists and courses to take from. But the courses themselves haven't changed. Some of them haven't changed. So that's something we need to address and talk about. And it's one key important we address here. So that the courses themselves need to be revised since they belong to these programs that already changed as well. So these GP programs struggle to make connections. And students, right, see that they lack interdisciplinary coordination. And they assume that they deal with basic skills because maybe we don't do a good job in explaining that these are foundations, and they need foundations, for example, to go to measures, because they won't be successful in measures if they don't have strong foundations. So these are some of the issues. And based on, of course, they're perceived that it's college algebra, it's a check, and they move on. So this is kind of what's going on now. So how can we make these connections? Of course, we're not saying we're going to solve every issue in this presentation, but we'll make some steps toward addressing an essential part. Here we're going to use integrative learning because it is a process, and integrative learning will help us go from point A to point B, and will do its process, its work there. So that's what we hope to do. This is just the subject, right? So if you have a different course, not even a math course, and it's in a general education, this presentation can apply as well. And technology, we use it, but we need maybe think about more of ways to use this technology in order to free some of the time for us to do this human connection. And we use Dr. Rita Pearson here image because she's a champion of this human connection. And if you see and some of her talks, and if you see or watch her TED Talk, you really understand the importance of human connection. And often we have it already. It just maybe not have enough time. And that's why we mentioned that technology role is supposed to do that, to free some of that time in order for the human connection to be there. So we're going to address human connection from 3 points. One, that it needs to be done based on Dr. Palmer on the courage to teach, that good teaching and good teachers, this, of course, we know it comes from our reflection of teaching, the identity and integrity of the teachers, and possess that capacity of connectedness. So this is the start. Now, are we, let's just do an example of a 60-minute lecture, for example. This is the block. Often we say we don't have enough time to cover anything, and so we barely have a minute, so we have to take this whole 60 minutes to do that. But if we look at Dr. Simon and Dr. Wiggins are talking about 2 important points. Learning results from what the student does and thinks, and only what the student does and thinks. And we complement it here with, it's not teaching that causes learning. So we need to address these questions to the style of the lecture, the style of the class, and ask, how can it apply here? So maybe this right side here should be this left side, and this other part be left to what the student does, and the student's attempt or the learner attempts to perform learning and all that. But it doesn't mean this is going to be separate or lost. No, it just means that the teacher can advance and influence learning, but what the student does. So there is some influence there. And there is a very important thing here, it's a feedback. Actually, Dr. Wiggins really explains it well, that if we just teach and keep teaching, only the students that already gonna be successful are gonna benefit, because there is a very important factor that needs to happen for other students, is that feedback. And there are some research that, of course, if we look at the curve, there is some small number of students that will fail no matter what. For example, you may have 5% of students will withdraw no matter what because of other issues that are even not relevant to the college or the school. And you'll have some students that will excel no matter what. It doesn't matter what format, how you teach and all that, these students are gonna ace the course and move on. But the influence area is huge. And for this influence area, as we see Dr. Simon here, and this feedback with Dr. Wiggins there are very important. And if we think about it this way, yes, we need to free this for something else. And I didn't talk about a very important point, but that we are addressing this challenge from a different perspective, because we often see the challenge being addressed from 2 points, either, for example, whether we need developmental courses or remediation courses, or whether we need co-requisite courses, for example. But here we're addressing, it doesn't matter what you need and how you do and what model, there is something else that needs to be done in addition to that, right? And so for college algebra, I think we should invest in learning the course, even though if we teach it for many years. We probably teach in college algebra for 20, 30 years. It doesn't matter. Based on this talk and Dr., for example, Gordon paper here, what's wrong with college algebra? We can see that there are 3 points. we talked about that the general education program changed, but the course, for example, college algebra probably didn't change, right? But the student population changed. So there is a change in demographic, and who takes the course changes. And the idea, for example, college algebra is for those going to calc track is not true, right? There is a very small number now of students. So it really depends on the college and the school. So it's worth investigating many ideas, right? The second point, the growth of technology and mathematics changes of needs and all that. So I think you can pause the video and go through these points, or get Dr. Sheldon Gordon article and see that if you teach a stats or other course, you can also investigate in your course and maybe just get some data from the school itself about success rates and measures and retention and all that. And it will give you a really, and demographic, that's very important as well. And understand how the change of the demographic now, and now we answer the question, what can we do in this course to address these changes? We picked technology to help us to free some of that time. Why? Because now if we look at the simple model, DIKW model, there are some other models, but this is the most basic one. And we can see that actually technology now can help us. We do a lot of work. We don't need to dig into data. We investigate and find out what students are struggling with and all that. Technology can do it. It can even give us insights and know what are the missing points, what students are struggling with, what the whole class is struggling with and all that. So it can do that. And we can change that to some type of wisdom. And that wisdom could be a change of instruction. It could be a feedback. It could be a feed forward, whatever form it is. But it does free a lot of time for us if we implement technology in that way, not just for the students to do their homework, right, on it, but also dig into the reports, use the reports, the insights and all that, to find out how to adjust and shift the course and what type of feedback, what is it that we need to do. So of course here we're not saying, sometimes if we focus on something, it may sound like it's a technology should replace, but no, based on the model, we're saying that the instructor has the role, and technology has a role, and there is a common thing they share. So one cannot replace the other, right? And you can find here many points that you can use technology to do for you. And of course, at the end of the semester, you can look at the reports and look into your students' results. And if a student don't do well in translating word problems, then probably technology did not do that well. And you can investigate by seeing what type of problems it presents and how it presents them, you know. So you can do that. And if you find out that technology is not doing a good job in this, then you can supplement that. So this also helps in reducing that amount of teaching, just-in-time reviews and all that, because you're leaving it to technology to do, but also you're fixing it at the end when you see it does not do a good job in it, right? So integrative learning, as I mentioned, is going to be a process. It's not the product. It's not, even though it's the main thing in the title, it's not really our product. It's more of a process in making and connecting all these. And you can find a lot of resources about integrative learning. And here is one definition there. But really, these issues are complex. because some may say, well, this is a simple thing, but really it's not simple. If nationwide there is an issue with the course and it's almost like 50-50 pass and fail, then it's a complex issue. So if this is going to be a process integrated throughout, so it needs a design. So here we'll talk about surveys at the beginning of the class, first day, where students share some data with you that's going to be helpful in these activities. For example, when they took a last math course and how was their experience in that math course, what do they expect from your course, and what major or interest, and what they plan to do with it. So this is very useful information. And of course, this will allow you also to tweak some of these activities to make them relevant subjects. And we'll talk about it when we get there, because some may say, well, if there are 10 different majors in this course, I can't address all of them. Yes, there is a trick to do that by letting the students address it. For example, if you ask them a very simple example to find an application in their domain or word problem or something like that, so they're going to find it and they're going to apply it and they're going to solve it. Then you just discuss it with them or let other students discuss it with them. So all this can be done in one way or another. Interdisciplinary idea, this also allows to connect these measures and maybe find a team sometimes. It helps. What is it that they all have in common? Or what is a team that can be applied to all of them? We focus on this for human connection, this modeling curiosity. It's very essential because a lot of people, I would say, based on some schools, they even have policies that conflict with this modeling curiosity. For example, penalizing a student if a student is even in your class. Let's say a student now did the assignment and stuff and pulled, let's say, a psychology book. Then, well, the policy, you're in math class, you open psychology, you're not interested in this math class, you get 0 for the assignment. Maybe we should model curiosity and find out why the student pulled this psychology book. I'm sure there is a lot of interesting things to do with psychology, and whether the student finished the assignment or the activity first or not. So there is ways to go, but a policy may not be a good way to go, because if it conflicts with this modeling curiosity, then it's going to affect this human connection, and human connection is going to be the essential key to make all this happen. And here, assignments or activities, whether they're discussions, whether they're surveys, whether they're talk, so they need to be designed from day one till last day. There are different type of discussions, and they can be spread out over the time, so students have one, to express, right, their ideas, and 2, to reply to other posts, and 3, to reflect on these. So these 3 key important parts, and you can pick different topics, different subjects, but I'll address some of them here. So for example, this first one can be about introductions, and all these need clear instructions. So all these need clear instructions and rubrics. It's essential because you have to give them some guidance, right? In the survey, we're talking about previous experience. Now they're going to talk about your current course. What is it they find difficult? What is it they find easy? And by doing these 3 things, they're going to exchange ideas. They're going to reply to each other. Yes, I find, so for example, when I did this last semester, graphing came up to be a big deal. Yes, they still find technology is does poorly when it comes to graphing, and they would rather graph these functions by hand and see what they mean. So that's a important feedback, right? And that will allow you to think about your assessment. So maybe now you give them the graph and you ask them for the equation, so you vary your assessments. And math applications, this is where that trick I mentioned, where they bring in their measures, they discuss it, they discuss some application that have to do with it, and here you have to be flexible because they find the stats. That's fine, as long as it's some type of quantitative method, it's okay. So this allows them to bring their, if we can give them examples that address all their measures, here it allows them to do that. Interdisciplinary, this is where, for example, you use a team. Let's say sustainability, how does it apply to your career or measure? What does it mean for me to be sustained as an instructor? So here we drop in a definition, and now they think about it a different way. It's not just the environment, but I can share what one of my students said. She's in nursing. She said, in order for one person to be a sustainable nurse, they have to have a dedication and compassion to be willing to help others, whether they feel tired, hungry, sick. They have to dedicate their whole day to help someone, care for someone physically and mentally. So you see, that's a powerful statement for a student to bring into college algebra. And after talking about it, to see now, how can math help you here? Is this some type of a program? Is this some type of routine? You know, and we get into that discussion and we give feedback. This is a simplified form, but of course, just one point that this is usually done in LMS, so it frees the time in the class, so it's done virtually and students are engaged with each other. And but if it's an assignment, I usually request essay or a PDF file, a brochure, a poster, a video, a media recording and all that, and give them rubrics and types for each submission so they know what type of quality is expected from them. And most of the works are essays, but I've seen a lot of poster and brochure style. A few videos, which and media or MP3s. But once students get comfortable, they would choose their own method to express it, and some URL if they post to a site. And we have graphic design students, so they even design their own page and post it. You know, the students would put comments whether they allowed for some of their works to be shared, and without their names. And after that, this is posted back in, some of these examples are posted back in LMS. So you can see that for this type of work to be happening in a math course, it's interesting because students don't expect it. And we're going to talk in the conclusion about its challenges, right? So what is the goal or the purpose from this presentation? It's to make these connections. General education or general education program to the course program. So for example, in our example here is college algebra, and the student. So, and the student. So these connections that we talked about, these three nodes, if we're able to make this, and if other instructors are able to do this in every general education course, this will help the picture to be more clearer, much better and much stronger. So it's all about making this connection. Integrative learning should start from syllabus to final tests. So day 1 to last day. It's a holistic program. It's something that addresses each time. Even for a few minutes. I know a professor that I saw his presentation, that first 5 minutes in each lecture would talk about a historical event that contributed, for example, to mathematics. So it could be that. It could be 5 minutes each time in the lecture time. It could be a few minutes and 10 minutes to do some type of activity after delivering the lecture. Student, of course, as I mentioned, did not expect to write. And now that's a new task. They appreciated the flexibility of topic and opportunity to research, but of course they don't have much developed research skills, so they need guidance. However, they find difficulty because some of the assignments have open-ended questions. And open-end questions usually are used, in math, for example, they're used to this. So if the answer is 6, it's correct. If it's 5, it's not correct, something like this. But now you're telling them, something else. So the example I give them here is, give me a few numbers or some numbers or a number that's less than 1, and you get multiple answers, right? So that's the idea. There is multiple numbers that will make this true. So if we talk about the solution, it'll be that interval. But the students can come up with the point that is a solution there. So we try to connect math and make it as analogies to this. So just because it's an open end doesn't mean you can find something. For sure you can find something, but it needs to be relevant to what we're trying to do. It was challenging to discuss own interest, even their own interest, because they're not sure yet, especially if they're first year. They know they want to be in engineering, but they haven't explored that yet. And they provide, however, they did provide creative work. I only put like an example of something there, but they did provide creative work. They invested the time to show, and some of them are competitive. They want their work to be displayed afterwards on those modules. And of course, we lead discussions and model curiosity because human connection is very essential, and this allows us to do that and provide that feedback and comments. And use a team such, for example, sustainability is something that is common interest to everybody, something they're interested in. And you can find that in the survey, allow group works. I don't enforce group works, but I allow group works 2 to 3 to students. This sounds like something they have to do as groups, but really I don't enforce the groups. Integrative learning is a process, so it needs to have a flow of ideas from the beginning to the end. Clear instructions are needed, especially with these open-end questions. Be ready to discuss online, so to be present online as well, and answer questions with some other leading questions. Why are you interested in this? What do you think we should do? What would be this? Okay, you picked this scenario. Do you think there is another scenario to this? And human connection is a relationship, or relationship is a key. And technology for sure can help us with remediation and skills. So we would like to thank you, Dr. Mahapatra and myself, for watching this presentation. If there is anything we can answer, please let us know. We thank you again, and stay safe, healthy, and take care of yourself.